Hello, everyone. Welcome to the day 15 and 16 quiz review. So tomorrow you will be having a quiz. This is on just days 15 and 16, but there might be a question or two that's a little bit of a review, but I don't think it'll be too challenging. And again, I'm going to apologize ahead of time for if you hear it's raining pretty hard outside. So just a warning, I'm going to try to talk a little bit louder and clearer so you can hear what I'm trying to say. So let's do some review so we're going to determining if something is independent or dependent, you're going to want to, we have some examples here. So for independent, it's for instance, if you're flipping a coin, when the probability of one event does not affect the probability of the next, or drawing a card with replacement, or drawing a marble. Basically, if you're selecting anything, and that key part is with replacement. Or you could be rolling a die. So something that's going to have the same probability of happening each time. And to calculate that, you're going to just take your probabilities and then you're going to multiply them by each other. And now for dependent, the occurrence of an event that does affect the probability of another, those are going to be examples that happen without replacement. That is your keyword. So think independent is with replacement, dependent is without replacement. And then you're going to solve your probability of the two events occurring, or multiple events. It could be more than two, but you're going to be doing that when you're just going to multiply those probabilities. And we're going to get more practice with it in the next slide here. So here's some example problems. So first, it helps identify if it's an independent or dependent event. So for each problem, we're going to do that. So for the first one, what is the probability of flipping 3 heads in a row? That's on a coin. So on a coin, it's two sides, either heads or tails. So since our denominator, where it's just 1/2, is for one head. Here, I'm going to retry that. Sorry, my pen's been a little wonky lately, so I want to apologize at a time. So head, then head, then head. So the probability of the first head is 1/2. And the probability of the second head is also... Oh, now my pen's going out again. Looks like I'm going to the cursor. So that's the first head. Probability of the second head is again 1/2 because it is independent. So that probability is the same. It doesn't affect the probability of another. And then the third head is also 1/2. So once you have all the probabilities, you're going to multiply them. And 1/2 times 1/2 times 1/2. Well, 1 times 1 times 1 for the numerator is just 1. And then 2 times 2 is 4. 4 times 2 is 8. And then once you get to your final answer, you're always going to want to simplify or reduce it. And this is as simplified or reduced as it can get. So that will be your final answer. Now for the second one, what is the probability of rolling 2 6s in, it should be 2 rolls. And 2 rolls of a die. Well, if you roll a die once, your probability of rolling a 6 is just 1/6 because there's 6 sides to the die. Okay, so there's your first 6. Now the probability of rolling your second 6 is also 1/6 because this is also independent. Remember how I said in your example? Again, I apologize for my handwriting. I'm trying to use my cursor. How I said rolling a die here is independent. This is rolling a die, so that is also independent. And then once you have those, multiply across, get 1/36. And that can't be further reduced, so that's your final answer. So now it's asking what the probability of drawing a red card, then another red card with replacement. So you're going to be drawing 2 cards total. So probability of the first red. Well, we know how many cards are in a deck total. Within each standard deck, there is 52 cards. And in that deck, 26 of them are red, and the other 26 are black. And if you reduce that, that's just equal to 1/2. So that's the probability of drawing your first red. Probability of red number 2 Since it says with replacement, we know that's independent, because that's another key phrase. When it says with replacement, we know it's independent. So probability of red on the second, since we replaced it, we still have 52 cards. And since if we drew a red on the first one and we put it back, there's still 26 red, which is equivalent to 1/2. So when you take those fractions and you multiply them by each other, so those two probabilities, you get 1/2. There goes my pen again. 1/2 times 1/2 gets you to 1/4. Now, last but not least, what is the probability of drawing 2 aces in a row without replacement? Since it says without replacement, remember that's the key phrase for when we're dealing with dependent events, because it says without replacement. Well, probability of drawing a first ace, so P of A, I'm back to the mouse again because my pen isn't working, is equivalent to, well, there's 52 cards. Again, each standard deck has 52, remember that. That'll come in handy. And there's 4 aces in a deck. So and that, if you reduce that, that's 1/13. Then probability of the second ace, here's the part that's a little different. Our denominator, instead of being 52, is now 51, because if you drew one card out of it and didn't put it back, so you took it off the top of the deck and you just kept it, you have one less card in that deck because you are holding on to the other one. And if we drew an ace in the first draw, instead of there being 4, there's 1 less, because that same principle that I just described, why there was 51 instead of 52 cards. And then you'll go through and multiply the 1/13 times 3 over 51, and that is equivalent to 3 equals, it's 3 over 663. But that can be reduced further. You can divide both by 3. So 663 divided by 3 is 221. So then you're left with 1 over 221. Okay, so that's some review for your independent versus dependent. Now we're going to move on to conditional probability. And conditional probability is the probability of one event given that another event has already occurred. So here are our little formulas that we have here. We have our notation. So remember, my little trick was that whatever is after, so this means given here, that little arrow, or not arrow, sorry, that line, that bar is given. And whatever is in the second spot after the bar is what's on the denominator. That's my little trick. So if A comes second, A is on the bottom. We'll do some examples. So what is the probability? So you either, in your quiz, you're going to either be given a question written out for you in the full sentence form like this, in the first one, or it's going to be given to you something like down here where it means probability of blue given country. So back to the first question, what is the probability that someone listens to pop music given that they voted red? So remember, probability of, to do that, so pop and red over red. It always helps me if I write that out and then go to the table and fill in this. So probability of pop and red here is 30. So then I'm going to write 30 in the numerator, and then over probability of red total is 120. So 120 is your denominator, and that's going to reduce. You can divide both by 10, you get 3/12, but then you can also divide by 3 and get 1/4. So that is equivalent to 1/4. Now, probability of blue given country, that's what that second one means. So again, I'm going to write it out. So blue and country, where they meet up, blue country, we have 5, that's our numerator, over country, because that's what's the second spot there. Country is 95, so over 95, and that reduces to be 1 over 19 if you divide both by 5. And last but not least, we have probability of country given blue. So these kind of flip-flop. These are 2 different questions. I want you to keep that in mind. They're not asking the same thing. So now, because it's still going to have the same numerator, because it's going to be the probability of them both happening at the same time, and blue and country meet up here at 5. And the denominator is total blue over 105. So 5 over 105, which reduces to 1 over 21 if you divide both by 5. Remember, I want you, and your quiz is going to ask you to give your answer as simplified fractions. These are the type of questions I'm meaning. So you're going to type in on your, on your computer, it's going to be like 121, like that. Sorry, excuse me. So remember to complete your attendance form, complete the review assignment, and complete the review quiz. Remember, if you have any questions, feel free to email.